Hello, this is Mr. Stansbury. I'm going to take you through the 11 F notes on volume. At the end of this, you should be able to say I can find the volume of various uniform, flat, and curved shapes. Okay, so let's get straight into converting units of volume. So if you look at these two things, these are actually the same size. It's 1 meter by 1 meter by 1 meter, which if you convert is 100 centimeters by 100 centimeters by 100 centimeters. Right? So again, we can use that by the little King Henry died unexpectedly drinking chocolate milk. Right? So from units out to centimeters, you go 1, 2. Right? So the volume of this here is 1 times 1 times 1. Right? 1 meter times 1 meter times 1 meter, which gives us a volume of 1 cubic meter. Volume of this here, which again is the exact same, is 100 centimeters by 100 centimeters by 100 centimeters, which gives us a volume of 1 with 6 zeros after it, which is a million centimeters cubed. Right? So if you think about it, to go from units to centimeters, you would just move over 2 spots. But since you had to do it for 3 different pieces, so for volume is 3 dimensions, you would have to move it over twice 3 different times. So we'd move it over. So here's our 1, and there's our decimal. We move it over twice 3 times. So there's 1, 2, 3 times, and again we fill in all those zeros. There's a 0 there, and look, you have 1,000,000 centimeters cubed, just like over there. Alright, so that's how you convert units. Okay, so without our pretty picture, let's try converting these here. 5 meters cubed to centimeters cubed. So again, actually that's just like what we did. So let's start with 5.0, and we're going to move, since it's meters, to centimeters. King Henry died unexpectedly drinking chocolate milk. Here we are at units, so we're going to go over twice for centimeters. So again, since it's cubic, we do that. We go over twice 3 times. So 1, 2, 3, 4, 5, 6. So that would be 5 million centimeters cubed. Okay. On this one here, if we are going to move our 25,000 millimeters, and we're going to shift that into centimeters cubed. Here's millimeters, and we got to go back 1 to get to centimeters. Right? So again, since we're doing it 3 different times, here's our decimal. You got to move it back once 3 different times because there's 3 dimensions. So 1, 2, and 3. So that would be 25 cubic centimeters for that. All right? Okay. Let's take a look at our next example, which is example 24 from page 381. It says calculate the volume of the uniform solid shown. Now uniform solid means that this side here, like if you were to take this block and cut it in half, it's going to look exactly like they're going to be identical. So this side here is the same on this, is the same basically as this other side. So it's a prism. Okay, so to find the area, the solids of uniform cross section, you basically just find the area of the end. So here's the area of the end, here's the area of the end, here's the area of our end right here, and you just multiply that by the height. Okay, so the area on this one is simply going to be 11.7 centimeters squared times the height, which is 5.9 centimeters. So you go through and calculate that. Let's see, let's turn that on, and we get 11.7 times 5.9. And we get 69.03 centimeters, and that would be cubed, because again we're talking about, I put area, that should be volume instead of area, shouldn't it? So it should be a V, not an A. So there is our V. So volume is 69.03 centimeters cubed for that one there. All right. Okay, let's take a look at another example. This is find the volume of the following here. So we have these two different shapes here, and again, you can just figure out the volume. Hopefully you remember that the volume of a rectangular prism is just length times width times height, and really that holds true with this the solids of uniform cross section. Basically you just find the base and multiply it by the height, right? And the base is the length times the width. So in this case we get volume equals 16.8 centimeters times 8 centimeters times 4.5 centimeters. Alright, so 16.8 times 8 times 4.5 gives us 604.8. And this is going to be centimeters cubed. Alright? Alright, so this next one over here, the area here, we're going to want to find the area of this circle here and multiply it by the height. So area is going to be the area of this, sorry, I keep putting area, it's volume, is going to equal the area of the circle, which is pi r squared times the height. So in this case we got pi times half of 14 is 7, so our radius is 7, so we'll do 7 squared, and that is centimeters squared, right? Times the height, which is 10 centimeters. So plug that into our handy dandy calculator and we get pi times 7 squared times 10, and we get 1539.4. Let's go with 1539.4 centimeters cubed. Alright? Alright, so let's take a look at a couple more examples. We'll try these two and then one last example after that and we'll be good to go. Calculate the volume of the solid shown to 3 significant figures. So now we're down here in pyramids and cones. So here's our pyramid. So it says find the area of the base and then multiply it by its height and then multiply that by 1/3. So, oops, the area here is going to be 1/3 the area of the base, which they actually give us. That's nice, 26.9 meters squared, times the height, which is 8.9 meters squared. Oh, just meters, excuse me. Alright, so we do 1 divided by 3 times 26.9 times 8.9. That gives us 79.8 meters cubed for that one there. Alright, so area equals 79.8 meters cubed for that one. Alright, now for this one here, the volume of the sphere is 4/3 pi r cubed. So volume equals 4/3 pi r cubed. So in this case, volume equals 4/3 pi times the radius is going to be half of 8.4, right? And that would give us, what, 4.2? Could make it so I could actually have room here. So let's do it over here. We've got room. 8.4 divided by 2 gives us 4.2 meters for the radius. So we do 4/3 pi times 4.2 cubed. So 4 divided by 3 times pi times 4.2 to the third power. All right, it gives us 310.3. 310.3, and this is going to be meters cubed. All right, one last example and we'll be done. So a box has a square base and its height is 12 centimeters. So let's just draw ourselves a little box here. It says that it has a square base and it's got, ooh, that was bad. That's worse. Still not so good. That's going to have to be close enough. Oh man, this is bad. Okay, go with it. That's ugly, but you get the idea. So it's got a square base and its height is 12 centimeters. So here's 12 centimeters, and we know that's square, so let's call each side down here x. The volume of the box is 867 centimeters cubed. Find its length. So volume equals length times width times height, right? So volume equals x times x. Well, let's see, we actually know the volume, so let's plug the volume in. 867 centimeters cubed equals the length, which is x, times the width, which is also x, times the height, which is 12 centimeters. All right, so this is 867 centimeters cubed equals 12x squared, right? X times x is x squared times 12. Divide both sides by 12 and we get x squared equals, so we get 867 divided by 12, 72.25, right? And then we've got to square root both sides to find out what x would be. So we square root our answer and get 8.5. Okay, so find its length. So the length and the width are both 8.5 centimeters. All right, that's all there is for this. If you have questions, please ask. And now you should be able to say, I can find the volume of various uniform flat and curved shapes. Thanks so much.